Back with an interesting topic of textiles, that is how do polymers arrange themselves in the fiber. Like we have already studied polymerization, so after that we need to study how polymers are arranged, in the manner they are arranged, and the properties of the fibers, why they are like that, why behaving like that, the reason behind that properties. So we need to study polymer arrangement. So today we are going to study about that. So the polymers are being bonded to the molecules arrange themselves in the fiber. But first let us understand certain points related to the fiber polymerization polymer system. It says the ratio of the area that the amorphous and crystalline region covers also differs. Like amorphous and crystalline regions, they are arranged in the fiber. When fibers are arranged in the fabric, we are making synthetic fabrics, we are making fibers, we are making yarns. So fibers arrange themselves, monomers arrange themselves to make polymers. So polymers are arrange themselves to make large polymers, right? So the area where they are arranged, all these monomers and polymers are arranged, it is amorphous or crystalline. So as we have studied in 6th or 7th standard, the arrangement of gases, liquids and solids, we have studied, right? So we have seen like solids, they're hard, atoms are arranged in a very tight manner, there is no space in between, right? And in the liquids we had seen that they are loosely arranged, they have much space in between as compared to solids. And in gases we can say that there are very less atoms, very less monomers in the gases. So like that, amorphous refers to the structure we can see like gases or liquids, and crystalline refers to solids here. The difference in the presence of amorphous and crystalline regions contributes to the specific properties of the fiber. The regions which are made in the polymerization process, whether it's amorphous, whether it's crystalline, they are responsible for the specific properties of any fiber. The ratio of the area that amorphous and crystalline arrangement varies in natural fibers during the growth. The ratio that the spaces in between the polymerization, when it is taking place, the process of polymerization is going on, the ratio of the area they are taking place, that depends. The properties of area, amorphousness and crystallinity in regenerated fibers can be controlled during the process. These proportions can be controlled in the regenerated fibers when they are made, because these are scientific processes, these are controlled experiments when we are conducting them, so we can control that. Next we have polymer arranges themselves in broadly two manners. Amorphous arrangement. The first is amorphous arrangement, as we have studied, when the polymers are lying in a random manner or exhibit no specific order, it is called amorphous region. As we have studied like liquids and gases, we have seen that in science experiments and the science practicals. So like that amorphous arrangement, there is no repetition of any manner in the arrangement of monomers or polymers. Due to the presence of random arrangement, the polymers can move easily when stressed under strain. When the fibers are stressed, the arrangement can be changed. They can't go under pressure because there is space. Features of amorphous arrangement, this is important as we will study the properties of fibers. So these features of amorphous arrangement or crystalline arrangement, these are important. Number one is better water absorbency and dye uptake due to larger spaces. The fibers which shows amorphous arrangement have very good water absorbency and they have very good dye affinity. Lower interpolymer forces, means hydrogen bonds or covalent bonds will not form there. Van der Waals forces will form. Lower chemical resistance, they have lower chemical resistance. They can't go with chemicals. They regenerate or they start spoiling in the hard chemicals. Soft handled and easily blended. They can be soft handled and can be easily blended and modified. Less durable. They are very less durable, means they can use for a particular season and something like that. They are not very much like, they will not go for very much long time. More of plastic look like. In this series, next we have crystalline arrangement. The polymers may be arranged in parallel bundles exhibiting more order are called crystalline arrangement or region. However, when the bundles of fibers are not only parallel to each other but also to the longitudinal axis of the fiber are referred to as oriented arrangement. Oriented arrangement, we have seen how things are when we are arranging something, how we place things in a particular manner. When we are placing things in the cartoon, when we are packing something, right? So that is somewhat like oriented arrangements or crystalline arrangement, means same manner will repeat after some time. So features of crystalline arrangement are less water absorbency and ion uptake. There in the amorphous region, water absorbency was much better and dye uptake was very much better, but here it's less absorbent and dye uptake is also, dye affinity is low. Strong internal forces. Here the internal forces like hydrogen bonds and covalent bonds will form due to the more of monomers and polymer arrangement. High chemical resistance, they upstand with the high chemicals. Stiff handle, they are not very much soft and can be mended easily. More durable, we can use these fibers or fabrics for longer times. They are more durable. Less of plastic, they are not like plastic. So with this picture we can see in this how the arrangement is going on, like in the fiber, how polymerization is in amorphous region and how it is in crystalline region. These are marked. So with this arrangement we can guess how the things are moving, how the fibers properties are, like that only. I hope you understand the basic topic. With this we can easily understand the properties of the fibers, how fibers are behaving and why they are behaving like that. Okay, tata, bye bye, see you soon in the next video.